So we will present our participation in a competition. Our team is Dataholics. It is composed of Sina, Ismail, and me, Badr. So we participated in a Kaggle challenge that involved many teams from universities all over France, including many teams from Université Jean Monnet. This competition is about a recommender website called 1001 Nights. So a recommender website is a website that gives you recommendations on hotels. You give it, for example, I want to travel here at this date, and it'll give you the hotels available and their prices. And for this competition, a government agency suspects that the recommender isn't being very honest and might have some illegal biases. And our goal is to investigate the website and see what these biases are. To do that, we are given two things. We are given the ability to make API calls and a test set. So what does this all mean? An API call is basically us pretending to be user to the website and giving it a user account where we are making this call, a language, a city, and date, and the recommender gives us everything that it usually gives to normal users. So hotels, how many places left in these hotels, and their prices. A test set is exactly this, but without the price. So a test set is, hey, this user made this search for this city on this date, and here's what the recommender gave him, but without the price, and we have to predict the price. There are some important rules to what we can do with these API calls. The first rule is that we cannot make the exact same call as something in the test set. Otherwise, the competition would be very easy. All we have to do is make the same API call. Other rules are meant to not alert the recommender website. So you can guess if the recommender website gets 1,000 searches a day normally, and then one day it gets 1 million searches, it'd be like, oh, maybe these 1 million people are not actual humans, but we're being investigated. So in order not to raise suspicion to the recommender website, we can make limited number of calls, of API calls per week, so that we lose ourselves in the normal traffic. And if we make an API, multiple API calls with the same user account, there are certain rules. Again, for the same reason, if a user, for example, speaks French and wants to go to London, and then the next day he speaks Hungarian and wants to go to Vienna, the recommender website will suspect that it is not a real user and might drop its biases for the recommendations to this user. So the second rule is that we can only make an API call with the same user with the exact same features except the date. So what does this mean? For example, we make an API call with the user Kylian Mbappé, who wants to go to Madrid. He speaks French, and he does his search on mobile. If we want to make another API call this user, we can only make it so that Kylian Mbappé still wants to go to Madrid in French on mobile, but on a nearer date, like 10 days before his departure, or 5 days, or 3 days, and then 2 days, etc. And our goal in this competition, we have two goals. The first one is to be able to predict the prices on the test set accurately. So that means that we captured the biases of the recommender, but the second goal is to write a written report that describes those biases in human language. Because we know that a big problem in machine learning is that for most algorithms, we don't know exactly why they make their predictions. So here we have to understand exactly why the recommender makes its predictions, and maybe some reasons might be illegal and dishonest.
So as all of us know that in this competition, the big challenge is that we don't have training set. We have to collect our data based on a strategy that we choose. So which makes always hard, because in each week we are allowed to only ask for 1,000 requests, which means that a combination of a city, language, mobile, and the dates before the departure. So what we do, we decided to collect our data proportionally, same as the Kaggle test set. By doing so, we hopefully could learn the underlying distribution of the test set, because finally we are going to be evaluated on this test set. So with a clarification of what I am saying, that imagine this test, this combination that I'm talking about. In the whole Kaggle test set, you can see the Paris, a person who wants to go to Paris and he's a Spanish-speaking person, he used his mobile and 5 days before the departure. Around 7% of the Kaggle test set is this combination. So we have in 3 months, each month has 4 weeks, so totally, and each time we can in each week actually get 1,000 requests. So we have in 3 months 12,000 requests that we can. So we will dedicate 7% of the total requests to this combination. But we want to get as near as possible to the target row of the Kaggle test set that we can. So what we do is that we flip the mobile parameter to the computer, or we just go one step behind or one step in the front. I mean, the date plus 1 and the date minus 1 will get us much closer to the target row of the data that we want. So here we come to the interesting part of this competition, which is, we call it dynamic pricing, that how a recommender system can overcharge people to get more money. So we have here 2 persons, the green person and the red person. Both of them made 4 requests to go to Paris. Same city and 4 times of requests. You can see the red numbers are the dates before the departure. But as you can see, the number of times that the user make a query is not enough. It is necessary to include as a feature, but it's not enough. If you can see, the date 21, 14, 8, and 3 are more spread than the green user 9, 6, 3, and 1. So the recommender system says that the green user has more rush. He's more intended to go to Paris. So let's take as much as money we can from him. And they do it. They actually do it. So I suggest that if you're going to Paris or another city, clear your cookies before using the website or recommender. And another feature that we add to this data set that we have is just we collected out our data, which means in a city, for example, Paris, the number of all independent hotels located in Paris and the number of all branded hotels. So the city which has more hotels, it is actually normally a more expensive city for a travel or something. And also the total number of available rooms in the whole city makes it change to the higher, I mean, actually it has a idea of the higher demand, the higher price that we have. So we added these 3 features to our common features that we have. Now Ismail is gonna.
Hello everyone. So in this part we come to what we are waiting for, which is what we did for this competition. And as Sina explained, like we did our way of collecting the data. And just before we go to the modeling part, we had like an extra layer here, which is we just like group the data based on the price range, as you can see in the picture. And just like if you are questioning, because we do not have the prices on the test set, we learned a classifier on the training set, and then we split it the same way the test set. So in the modeling part, we tried a lot of models like linear regressors, like polynomial regression and everything. And like just here, we are presenting the regressors that gave us good results. The best one was CatBoost, which is just like a decision tree based model. And we had like the best score on the training set, about 15, and on the test set, on the Kaggle test set, about 19. So again, we tried the XGBoost, which is like a good model for the regression tasks. And we also tried linear regression and random forest. For the random forest, we did not have like the accuracies because we could not, it could not converge. And just this because of the training samples we had. We had like around 400,000 rows, and we did the random forest for the grid search on a lot of parameters, and it could not run. It was like running for 1 night, and it could not converge. So again, what we are working on right now, which is like the matrix factorization. As I said, like we had a lot of features, and we are doing the interaction between them, but we could not get good scores.
And now we have like the matrix factorization, which takes into account like the interaction between the features and also the feature values. And for this model, we are having like a better score as what we had before, which is like the 19. And now we are getting improved. And also like for the test set on the Kaggle competition, we are doing like very well. So again, we are also working on the metric learning, which is we are doing some clustering on the data, and we are using only the Euclidean distance. So we are trying to learn a metric on our like data set, and which is also like it's giving us some good improvements. Again, the last part we are working on, which is the clustering of the authors. Like we are doing like the predictions based on the rows, and we just were thinking about clustering the authors and then doing making one model per cluster. So thank you very much for your attention.